For this particular job, we had an interesting sloping site with a significant height difference of 8 meters between the highest point to the lowest point. The site sloped away from the road, which presented its own challenges. When designing a building on a sloping site, the considerations can be quite different depending on the direction and magnitude of the slope and the budget of the homeowner or developer. For this particular site, we had a number of design considerations which we used to deal with the 8-meter slope. After the lower retaining walls are built, we commence with cutting and leveling the lower slab area. The critical points of the building are marked by our surveyors, and we also pin the profiles, which are placed away from the building on the side boundaries of the site. This way, when we eventually lose the main surveyor's pins, we can retrieve those pins using the offset pins which we have on the profiles. As the concrete slab is split between the lower and upper slabs, we require a retaining wall between the two concrete slabs. We commence the retaining wall construction by excavating the retaining wall footings. In this case, as the retaining wall was to be connected to the upper slab, the design required a 600mm deep by 400mm wide footing. While we have our machines on site, we proceed to excavate the rear pier footings. These footings will support the rear steel SHS posts, which will be set to height and will be the supporting structure for the suspended timber floor system. When excavating pier footings, it is important to leave the pier holes as clean as possible and free from loose soil. It is critical that our concrete footing is placed onto a clean and solid foundation that will not settle and sink over time. To remove any remaining soil from the bottom of the pier holes, we use a special clean-out attachment at the bottom of our excavator's extended shaft. Once the retaining wall footings are excavated and cleaned from loose soil, we proceed to place the reinforcing steel. The details of the steel cages, thicknesses of bars, ligatures, corner bars, concrete cover, concrete strength and other characteristics are provided by the project engineers in the structural engineering drawings. If there is any confusion on site about any of the details or any unforeseen site conditions are encountered, which is not uncommon, it is important to raise these with the project engineers as soon as possible so that the details can be clarified or an alternative solution can be proposed. Once the reinforcing steel has been placed correctly and the footings have been inspected and approved by the project engineer, we can proceed to pour the concrete. In this case, we use a line pump to pump the concrete from the concrete trucks on the street to the retaining wall footings. Our concreters use a laser level to screed the concrete to ensure we are left with a smooth and level surface. We are now ready for the block layers to begin building the retaining wall. The retaining wall footing is once again pinned by our surveyors, giving the block layers the precise location of the block wall. The first course or bottom course of blocks is a special clean-out block which has an open face. These are used to clean out any mortar which falls inside the wall during the construction process. Reinforcing steel is placed vertically and horizontally at regular centers inside the block wall. The details of the thickness and spacing of the reinforcing steel is again shown in the structural engineering design. Once the block wall is built, the structural engineer returns to site again to inspect the wall and the reinforcing steel. Once approved, the block layers can close off the bottom course of blocks and we can core fill the inside of the block wall with concrete. Once the block wall is complete, the underslab plumbing has been installed and approved, we can move on to the lower slab. Compactable fill is delivered to site. Our concreters begin by spreading and shaping this fill to the correct heights. The perimeter of the slab is then boxed or formed up to the right height and at the precise location provided by our surveyors. For this particular slab, we used a waffle pod design. Polystyrene pods are used at regular spacing to create a void inside the concrete slab. We leave spaces between each pod which creates an array of thickening beams throughout the slab. This, along with many other details, are provided by the project structural engineers and can be found in the structural engineering plans. Once again, we use a concrete pump to pump the concrete from the street to the slab area. In this case, we use a boom pump, which was preferable as the pump hoses are elevated overhead and do not obstruct the work area. Once again, we use a laser level to achieve the correct heights. Our concreters screed the concrete for a smooth finish. The concrete block wall has now cured and we are ready to backfill. The back of the wall is waterproof to protect the inside of the building from intrusion of moisture. We protect the waterproofing membrane with a layer of core fluid plastic. At the bottom of the block wall, we use a slotted Aggie pipe which is connected to the stormwater system. We then backfill the retaining wall with drainage gravel. This system ensures that any water that is found in this area will be able to flow freely through the drainage gravel into the slotted pipe and through to the stormwater system, avoiding a buildup of moisture and pressure behind the retaining wall. Once the backfilling is complete, we clear the area of any excess soil and create a flat pad ready for the upper slab. As with the lower slab, we use a waffle pod design. The process is generally the same. We use a concrete vibrator to remove any air pockets. A laser level is used to achieve the correct heights, and our concreters screed the concrete to achieve a smooth finish. This concludes the base stage of the construction process. Due to the slope of the site and the split level design, the base stage was significantly more complex, timely and costly for this particular project in comparison to homes built on flat sites. From here, we move on to the frame stage. We begin with the rear suspended timber floor system mentioned earlier. As with the base stage, the construction of the frame for this project was significantly more complex due to the split level design. However, from our experience, homes with these types of complexities and design features which are built on unusual sites can often result in an end product which is more interesting and has more character than a standard home built on a flat site. We were certainly happy with the end result of this project.